time. It seems to rule everything we do. Yet have you ever really thought about how important time is to us? You see, sitting amidst the hours and minutes of our day is our forgotten little friend, Sammy the Second. Often overlooked, Sammy's not only the heartbeat of time, but he plays a crucial part in another area of human progress: navigation. But what does time have to do with navigation, you ask? Well, got a second to find out? It all began long ago when sea explorers carried clocks on board their ships called chronometers. These clocks were set to the exact time as a clock back on land, and together with observing the sun, moon and stars, they could determine their longitude and latitude. This process allowed maps to be drawn so other ships could know where they were going. Amazing! However, clocks back then weren't very accurate, and if a ship's chronometer drifted off by even a few Sammys from the main clock, it could mean the difference between finding their destination and being hopelessly lost. Today, time is a precise part of a type of navigation called the Global Positioning System, or GPS. Yes, boats, planes, cars, and even our very own smartphones receive data back from orbiting satellites that calculate our longitude and latitude coordinates. This allows you to arrive at a destination within feet.
Pizza.
So you see, down here on Earth, it's only because of time, Sammy, that we can know where we are and where we're going. But what about in space? Not just space, but deep space. How do you navigate and explore a place where there are no longitude and latitude lines, no orbiting satellites to help? Right now, scientists navigate spacecraft by using giant antennas here on Earth. No, not those kind. These kind. Just like the old sea explorers and our GPS, these antennas send out a signal that is bounced off the spacecraft straight back to the Earth. Scientists then measure the time it took for this round trip, and that's what determines the spacecraft's distance and speed. While bouncing signals off our spacecraft works, that isn't the most efficient way to navigate deep space. You see, the antenna can only talk to one spacecraft at a time, leaving others waiting for up to a day. And then by the time the signal's calculated and sent back, the spacecraft isn't in the same spot anymore and the results have to be adjusted. So, how can deep space exploration become even more efficient, exact and precise? How can a spacecraft's navigation as it travels further and further into space be more immediate and independent of having to check in with... What's that, Sammy? Of course! The Deep Space Atomic Clock. Scientists and engineers have now developed a way for the spacecraft to have its own on-board clock, so it no longer has to check in with Earth for its coordinates. This breakthrough device is smaller, self-sufficient, and can handle the harsh conditions of deep space. Now the spacecraft can make immediate course corrections on its own, and land with incredible precision. So you see, our little friend Sammy the Second is finally getting his due, paving the way for more precise and efficient space exploration, one tick-tock tick at a time.